All right, let's take a look at number 4 in section 10.2. We're going to consider this infinite series here, and we're going to find the formula for the partial sum of the series. I think it's always helpful to just list the terms of the series that we're adding. So when n is 1, I get -1 to the 1 minus 1 is 0. -1 to the 0 power is 1. When n is 2, I get 2 minus 1 up here, -1 to the first power. Then I'll get -1 squared, which is +1 when n is 3. When n is 4, I'll get -1 cubed, which is -1. And you can see what's happening, right? We're adding, alternating, uh, uh, between 1 and -1. These, again, are what we call, we refer to these as the a sub n, right? We're looking for the formula for the partial sum, s sub n. So remember how that works. S sub 1 is a sub 1. S sub 2 is a sub 1 plus a sub 2, so 1 plus -1, which is 0. S sub 3 would be the sum of the first 3, which is back to 1. S sub 4 would be the sum of the first 4, which is back to 0. So we can see clearly what's going to happen for our sequence of partial sums. It's going to alternate between 1 and 0 forever. And notice the odd terms in our sequence, S sub 1, S sub 3, S sub 5, are all 1, and the even ones are all 0. And so the general term or formula, if you will, for S sub n can be written this way. It's equal to 1 if n is odd and 0 if n is even. Excuse me. And then that, I think in this problem, is like a multiple choice. So this is one of the choices for the formula for the partial sum. Now, does the series converge or diverge? Well, the series will converge or diverge if the sequence of partial sums converges or diverges. Well, explicitly, I guess I should say, this series will converge if this sequence is convergent. This series will diverge if this sequence is divergent. So remember, when a sequence is convergent or divergent, we need to look at the limit of the sequence. The limit as n goes to infinity of the S sub n's. If that limit is finite, then a real number, then the sequence is convergent and the corresponding series is convergent. If the limit of the sequence is infinite, plus or minus infinity, or does not exist, then the series is divergent. Well, what is it? Since the limit as n goes to infinity of S sub n does not exist. Why? Because we keep bouncing back and forth between 1 and 0 forever. It never settles down to anything. It doesn't get close to anything. The series, therefore, the sequence diverges, and therefore the series also diverges. Okay, hope this makes sense.